We're going to start real quick with a review of what we've been doing for the last 2 days. And you'll see why here in just a second, I hope. Okay? How do I solve a problem like this? What is my thought process when I see a problem with absolute value in it? I've got to do 2 equations, right? I need 2 equations. So my first equation is x plus 5 equals 6. And my second equation is negative x plus 5 equals 6. Okay? Now, a couple days ago when we started this, some of you asked me, couldn't we just make the 6 positive and the 6 negative? Because after I divide both sides by -1 here, don't I just get x plus 5, equals -6? So isn't that the same as rewriting what's inside and making this positive and this negative? Several of you said something to me like that. Okay? Do you remember what I said? I said, I need you to trust me here. You'll see why in 2 days. It's now 2 days, right? This is when I'm going to show you why what we want to do is make the inside positive and the inside negative. Okay? But for now, let's just continue our review of what we did. Okay? So here on this first equation, I subtracted 5 from both sides and got x equals 1. And on this side, yes, I did divide both sides by -1, and then I subtracted 5 from both sides again and got x equals -11. Then before I plot it on a number line, what do I need to do? Check, right? So if x is 1, 1 plus 5, 6, good. Absolute value of 6? 6, does 6 equal 6? Yes, so this one works. That one's good, okay? If x is -11, -11 plus 5. -6, what's the absolute value of -6? Does 6 equal 6? This one also works. What's left to do to solve this problem? Just the graph, right? The number line. So I draw on line paper and I still can't even draw a straight line. Sorry about that. 1, 0, -11. Okay? So what goes where on this graph? What do I put? Yeah, I put dots at 1 and I put dots at -11. Now, truly, like really, is this number line necessary? Not really, right? I'm saying the answer is 1 and the answer is -11. But once again, we knew where we were going. So we said we're going to have them do number lines here because we know where we're going and we're going to need them to be ready for number lines. Okay? So this is the problem that we were doing to review. Here's the problem, the new work for today. How is that different? When I go to solve it, how am I going to do it different? So basically in the beginning, I'm not going to do anything different, am I? It's still absolute value, so I still need 2 equations, right? I still have to isolate the absolute value. It's done. So I still need 2 equations. And one of those equations is x plus 5 is less than 6. And the other one is negative x plus 5 is less than 6. So in this one, all I do is subtract 5. X not equals, x is less than 1. Right? Here's where it matters. Because when I go to divide both sides by -1, yeah, I get x plus 5. Yeah, I get -6. Yes, it does. Absolutely. I have to flip that inequality sign. That is a very question, and if you want to be honest, that's exactly what I was about to ask you. Do you know why? Can I show you? Can I show you? Is that okay? Okay, I'm going to come over here to the side in my work real fast. And I'm going to say to you, 5 is less than 8. Is that a true statement? Is 5 less than 8? Okay, so I haven't said anything wrong. Okay? So what if I added 4 to both sides? Is 9 less than 12? So adding doesn't change the inequality sign, right? Would it change if I subtracted 4 instead? And I got 1 is less than 4? That's still a true statement. So adding and subtracting doesn't matter, does it? What if I divided by 3? Is 3 less than 4? Yes, that's still a true statement. But watch this. If I divided by -3, is -3 less than -4? No, it's not. If I don't change my inequality sign, my statement is no longer true. Okay, the example I showed you was division by a negative sign, but what else do I have to watch for? Multiplication. Absolutely, multiplication by a negative number also changes. Okay, that's why. Because our statement is no longer true if I don't change my inequality sign when I divide by a negative number. Okay, so back down here, now we see why this is greater than now, right? Then I subtract 5. Again, the same thing that I did up here in the original problem, right? X is greater than -11. What do I have left to do? Check and graph. I already know it's right, because it's exactly the same thing I did in the previous problem. When I go to graph, though, this part is definitely a little different. Okay? I still have a -11. I still have a 0. I still have a 1. But is 1 an answer to this inequality? 1 plus 5 is 6. Absolute value of 6 is 6. Is 6 less than 6? No. Absolutely. That's exactly right. On 1, I have to put an open circle. You guys are remembering this, right? Okay. Open circle on 1, and I'm saying less than 1, so it's going to go that way. I'm eventually going to shade to the left, right? But let me look at my other part, because my other part is x is greater than -11. So again, for the same reason, it's just greater than, it's not greater than or equal. I have an open circle on 11, but it's greater than that, so I would shade that way. So where am I going to eventually do all my shading? In between them. Guys, now do you see why I had you change the sign on the inside rather than the sign on the outside? Because if I would have taught it the other way, I would have to reteach it this way for inequalities. Or if you look at some textbooks, like our textbooks 2 times ago, they have you remember like 4 or 5 rules. If it's this, you have to do this. If it's this, you have to do this. I don't want to remember rules. I don't like them. Okay? I want to be able to have one way that works almost every time and be able to do it that way, whether it be equations like our first example or inequalities like our second example. And guess what? It does. Okay? So here's the deal. Can someone please tell me a possible answer to this inequality? One possible answer. -5. -5 is about right here-ish. Is that part of my answer? How do you know? It's in the shaded part. Okay? What's another possible answer? 1/2, which would be like right there. It's 1/2 in the shaded section. Then it's a possible answer, right? Now, you guys are the first class all day, which shouldn't surprise me, that said something besides an integer. Everyone else is like -5, -4, -1. And my question to them is, why did you always choose an integer? Because isn't it -5.3264278? Is that also an answer? Yeah, but people don't like those numbers, right? They want just -5. I just want you to make sure that's in the back of your head. All the numbers, every number in between 1 and -11 are possible solutions. So how many possible solutions are there? That really messes with my brain sometimes. I have 2 endpoints. There should be a certain number that I could count to in between those 2 endpoints. But there's not, is there? If it messes with your brain, that's okay. Right? That is okay. It's weird. It's weird to think about stuff like that sometimes. But I think I'm weird, and look how amazing I am. So it's okay. Right? All right. So what if I gave you this problem? And here's my work. And then I got x. Stop judging me. X is greater than or equal to 4. X is less than or equal to negative 2. What would that graph look like? There's a 4, there's a 0, there's a negative 2. Oh, I'd have a closed circle at negative 2, and I would be shading to the left because it's less than or equal. And a closed circle on 4, and I'd be shading to the right. Is that okay? Is that allowed? So I would shade over here, shade over here. Can you guys tell me a number that's greater than 4 and less than or equal to negative 2? I can't think of one either, right? Is there a number that's greater than 4 and less than or equal to negative 2? But who said it had to be and? It is, isn't it? This is or. Is this one and? Is this one and? Yeah, this one's and. It's greater than negative 1, or sorry, greater than 1. X is less than 1, and it's greater than negative 11. Here it's or. They're going two different directions. Is 5 an answer to this inequality? Does it matter that 5 is not less than or equal to negative 2? No, because it's greater than or equal to 4. Okay? So let me try to trick you. Is that okay? Of course it is. Absolute value of x plus 3 is greater than negative 2. First thing you want to say is what? No solution, right? Because yesterday and the day before we said if it's absolute value and it's negative, can't happen. But, that's the most important word, is but, right? This time, what's true? So what number can I put in for x that will give me a value that is greater than negative 2? Anything. Because you already told me that when I take the absolute value, it's going to be positive. Doesn't matter what I put in for x, I'm always going to get a value that's greater than negative 2. But, so if we put in like negative 6, negative 6 plus 3 is negative 3. Absolute value of negative 3 is 3. 3 is greater than negative 2. Good question. Good question. Okay? But we have to go back to what I was saying for just a second, right? But, don't. That is no solution. Why? No matter what I put in, it's going to be a positive number, and no positive number will be less than negative 2. Yes, I am. Thank you. Questions? All right. Peace.